This lesson will make you go through the introductory concepts of greedy algorithms. Before we begin, let's consider a situation. There is this very intelligent guy who knows programming. He's very rich and has an infinite supply of $20, $10, and $5 coins. Now, he has a friend who needs some money. He asks for $35 and that too in minimum number of coins. Now, if he was just to give money, he could have given it in quite a number of ways. He could have given 7 coins of $5, a $10 coin, and five $5 coins, and so on. But since he is supposed to pay minimum number of coins, he has to come up with a greedy idea. After thinking for a while, he proposes a solution. For every iteration, he has to give a coin of the largest value that does not take him past the amount to be given. Now, for $35, the largest denomination he can start giving is $20. Now, $15 are short to the amount, so the next largest he can give is $10. Now, he needs $5 more. And since he has it as a denomination, 1 coin of $5 and the loan is just given in 3 coins. Here the thing to note is that after every iteration he is making a choice. One which is greedy in nature, giving the coin with the largest value possible. This method will however not work for all denomination and currencies. Now we will formulate the idea of greedy algorithms. Greedy algorithm follows problem-solving approach of making the locally optimal choice at each stage with the hope of finding a global optimum. So at each stage we select a locally optimal value with the hope of getting the best possible solution. This is a useful programming methodology. Let's see a few of its pros and cons. So this approach is simple, easy to code, implement, and have a reasonable running complexity. However, the main drawback for the method is that there are very few cases wherein we end up getting the globally optimal value. With this example, we'll see how the algorithm makes locally optimal choices, however ending up at a non-optimal solution. So, in this tree, we are required to get the largest root to leaf sum. That is, starting from the root node here, we have to find a path ending at a leaf node and having a sum of nodes as maximum. So let's start from our root node. The sum at the start is 3. There are 2 possible paths, 4 and 7. However, here we have to make a greedy choice and choose that one that is maximum. That is 7. Our total is now 10. Now once at 7, we have to choose between 9 and 11. The greedy choice would be to select the larger of the 2. Therefore, we select 11 and end up having a path with a sum of 21. Can we do better than this? Yes, we have a path. If we start from 3, go to 4 and then to 20, this path would give us a sum of 27, which is greater than the one we achieved through the greedy method. So here we conclude that making locally optimal greedy choices don't always give us a globally optimal value. So when are we supposed to use greedy methods? All problems which are generally solved using greedy algorithms satisfy 2 properties. The greedy choice property, that is making the best choice at a moment leading to a global optimum. Next property is the optimal substructure. Problems whose optimal solution can be constructed efficiently from optimal solutions of its sub-problems. This property may look similar to one in the dynamic programming. However, one thing to note here is that the greedy algorithm never reconsiders its choices. That is the main difference from programming or dynamic programming, which is exhaustive and is guaranteed to find a solution. Finally, we look at some applications which use greedy algorithms. Activity selection problem, Huffman coding, job sequencing problem, fractional knapsack problem, Prim's minimum spacing spanning tree are a few of such applications. Stay tuned for our next lesson on topological sorting.